Back in 2017, Google dropped a paper called Attention is All You Need. It gave us the transformer, the architecture that powers, well, everything now. From ChatGPT to Gemini, it was a genuine lightning in a bottle moment that literally changed AI forever. So the big question floating around right now is, did they just do it again? There's a new paper out on something called nested learning, and the buzz is that this could be the next massive leap. Let's get into it. So here's the deal. The original Transformer paper was all about the what. It was a revolution in understanding the contents of a huge pile of data. It's about static knowledge. But this new idea, nested learning, is aiming for something way more profound. It's not about the what anymore. It's about changing the fundamental how. It's about turning the AI from a fixed, static tool into something that can actually evolve. All right, so here's how we're going to break this all down. We'll kick things off with what I'm calling AI's Memento problem. Then we'll dig into the big illusion this paper is trying to shatter, explore their solution of learning at different speeds, take a peek inside their new Hope engine, and then wrap up by talking about what this all might mean for the future of AI. Okay, let's start with section 1, AI's Memento problem. You know, this really gets to the core of a frustration I think we've all had. How can these incredibly powerful AIs be so incredibly forgetful? This quote from the paper's lead author just hits the nail on the head. Antirograde amnesia. If you've ever seen the movie Memento, you know exactly what he's talking about. You remember your entire past perfectly, but you are completely incapable of forming new, permanent memories. Your world basically resets every few minutes. And that describes today's AI perfectly, doesn't it? It knows everything from its initial training flawlessly. But the second your conversation gets too long and falls out of that context window, poof, it's gone. The whole conversation never happened. You can spend an hour teaching it something, and it will learn nothing. It never, ever actually gets smarter by talking to you. So why? Why is it built this way? Well, that takes us to section 2, the great deep learning illusion. The authors of this paper argue that this amnesia isn't some fundamental law of AI. It's an artificial wall that we, the developers, have built right inside the AI's mind. You see, for years, we've had this strict separation. On one side, you've got the architecture. Think of it as the AI's skeleton. It's rigid, static, and completely frozen after its initial training. And on the other side, you have the optimizer, the sculptor. This is the tool that shapes the AI during training. But once that's done, we lock it away in a toolbox, never to be used again. This split creates this bizarre mind of extremes. You've got the attention part, which is infinitely fast. It's paying attention to every single word you're typing right now. But then you have the MLP layers, where all the deep core knowledge lives. And those are infinitely slow. Their update frequency is literally 0. There's this massive, empty chasm between real-time learning and permanent knowledge. And this is where the paper drops its bombshell. It says this sharp line we've drawn between the model's structure and its ability to learn, it's not real. It's just an illusion, a convention we've been stuck with. And then they ask this really profound question. What if the architecture and the optimizer aren't two different things? What if they're the same thing, just moving at different speeds? And that idea brings us to section 3, learning at different speeds. So if the problem is this giant gap between infinitely fast and infinitely slow, how do you fix it? Well, you do what smart engineers have always done. You look to nature's best design, the human brain. Now, this is the part I find absolutely fascinating. They took their inspiration straight from neuroscience. You know, our brains don't just have one speed. They operate on different frequencies, right? You have fast gamma waves when you're thinking hard, and slow delta waves during deep sleep when you're consolidating memories. And that is exactly what nested learning tries to build, an AI with different layers that update at different speeds, just like our brainwaves. So here it is, the big idea in one sentence. Nested learning says that the thing that learns, the optimizer, and the thing that knows, the architecture, are actually two sides of the same coin. The best analogy is a complex machine full of interlocking gears. You've got tiny, fast-spinning gears for what's happening right now, medium gears for what happened today, and huge, slow-turning gears for core, permanent knowledge. Okay, the theory is pretty cool, but how does it work in practice? Let's pop the hood. In section 4, we're going inside the Hope engine, which is the actual framework they built to make this all happen. Hope is basically made of 3 key parts working in concert. You've got a fast memory system called Titans, a slow memory system called CMS, and a brand new kind of teacher or optimizer called M3, which knows how to handle this new 2-part memory. And here's where that brain analogy gets really, really good. Titans is designed to act like our hippocampus. It's the short-term memory. It's constantly looking at the new information coming in and deciding for itself what's important enough to pay attention to. Then you have CMS, which is like our cortex, the long-term storage. Important things from Titans slowly trickle down into CMS, sinking into layers that update at different speeds, becoming permanent knowledge without just wiping out everything else. This is the key to solving catastrophic forgetting. But get this, they didn't just give the AI a better brain, they gave the teacher a better brain too. The new M3 optimizer has its own memory. It has a fast component to see what's happening right now in the training, and a slow component to keep track of the big picture. And you can see from the results, this new memory-aware teacher actually trains the AI better and faster than the old methods like AdamW. So, when you put all these technical pieces together, what do you have? This is where we get to section 5, because the implication here isn't just a slightly better model, it's a complete redefinition of what an AI model even is. Think about it. For the last 10 years, the whole game in AI has been deeper is better. We just stack more and more layers, make the models taller and taller. But this paper asks a really powerful question. What if we've been chasing the wrong kind of depth? What if real intelligence doesn't come from a taller building, but from a deeper, more complex rhythm of learning? And this leads to a definition that will honestly kind of break your brain for a second. The paper says that pre-training, that thing we thought was a one-time event, is actually just ultra-long context-in-context learning. That erases the line between training and using the AI. The model is always learning, just at different speeds, on different timescales. It's not a static product anymore. It's kind of like a living organism. So, is this it? Is this the next attention is all you need? For our final section, let's take a look at how the rest of the AI world is reacting to this pretty radical new idea. Well, as you might guess, the opinions are all over the map. You've got the optimists who are basically shouting, this is version 2.0. They believe this gives AI metacognition, the power to learn how to learn. Then you have the pragmatists. They're just excited that this could finally solve catastrophic forgetting, which would save companies literally millions of dollars. And then, of course, you have the skeptics. They're pointing out that the math feels a bit hand-wavy and that trying to tune all these different learning speeds in the real world could be an absolute nightmare. But look, whether this specific framework takes off or not, the vision here is just undeniable. This final quote from the paper really captures the sheer scale of the ambition. For a true intelligent agent, existence is compression and living is learning. It's this idea that intelligence isn't just about having knowledge, it's about the continuous act of learning itself. And that really leaves us with the biggest question of all. For years, we've gotten really good at building machines that can mimic the output of human thought. But a paper like this makes you wonder if we're turning a corner. Are we finally moving past teaching an AI what to think and getting closer to teaching it how to learn?